Okay, so you have a function defined by an integral, and I purposely make these functions to be impossible to integrate. If you try to do any kind of u substitution or anything, you won't be able to integrate. Okay. So when you have a question like this on the exam and it's not asking you to actually do the integral, don't bother. It's not going to work. Okay? And both of these questions will be solvable without ever computing the integral itself. So let me show you how. First, let's see what h of 0 is. Well, h of x is this thing, so when you plug in 0 here, that means all the x's here should be replaced by 0, right? What is this?
0.
Yeah, because 0 squared is 0, 0 times anything is 0. So 0. Now what about h of 1 then? H of 1 would be 1 squared integral from 2 to 2 sine of t over t dt. Now what's this value now?
0.
Why? Why is it 0?
The integral would equal 0 after.
Yeah, so if you have the same number top and bottom, that integral will be 0. And I'll try to explain this in two ways. One is that the meaning of the definite interval is the area under the curve over some interval, right? But the interval is from 2 to 2. What is that? That's like 0 length interval. So no matter how high your function is, it's base times height, and the base is 0, so you can't have any integral value. It'll be just 0. Okay? That's one way to say it. Another way to explain it is like, although you can't integrate this, let's assume for a moment that we can. Okay? Then let's call the antiderivative as, say, g of, or f of t. F of t. Then the fundamental theorem of calculus says, write down the antiderivative, which is capital F of t, and then you plug in 2 and 2, which means you do f2 minus f2. But whatever f2 is, you're subtracting f2 minus f2. That's going to be 0, right? So again, that's how you can argue that this is 0. So you can, rather than trying to memorize same thing should be 0, just know that graphically this is 0 area. So that's going to be 0. Now, however, if you ask a different question, what's h of 2? Now you're in trouble. Right? H of 2, then 4, 2 to 4, that's 4. And you have something you can't integrate. In that case, what can you do? You don't know the antiderivative, so the best you can do is something like Simpson's rule. You can only find the approximate value. But nonetheless, you can find the value of h of 2 with any accuracy you want by using finer and finer rectangles to cover that interval. Okay? All right, let's now move on to B. Find h prime of 1. So that h prime of 1 means you have to find h prime of x, and then you have to plug in 1. That's what it means. So you need to find h prime of x when the function is defined as an integral. So we're first going to try to find h prime of x. And I realize that this is quite challenging, especially when this is not just that. If this was just x, then you can use the formula for the second fundamental theorem of calculus. But as I said, the formula you get for second fundamental theorem of calculus is useless. Don't even bother using it. Okay. So instead, try doing what I suggest. So step one, what you want to do is denote the antiderivative of the integrand as some function. Okay, so I'm just going to say that integral of sine t over t dt equals to capital F of x, I want this to be x. Capital F of x plus c. So that f of x is the antiderivative of sine x over x. Because we don't know how to do the antiderivative, we'll just give it a name. And we are going to act as if we know it. Fake it till you make it. That's the idea. Just give it a name and then see where it leads. Now, there isn't much that we know about f of x other than just one thing. We just know its derivative. What is f prime of x?
Little f of x.
Hmm?
Little f of x.
But what is our little f of x in this context?
H1.
No, it's not.
No.
It's not h. You integrate this to get capital F. What's the derivative of f? Then? Sine x over x. Yes, yes. If you integrate this to get that, then you differentiate that, it will give you this. Obviously, right? And that's what you want to write down. Your step one should always be assign a name for the antiderivative, and then make sure that you remember that the derivative is what's inside the integral. Okay? That's something that you should do for all of these questions. Just assign that. Okay? Now, step 2, use fundamental theorem calculus 1, not 2. We learned something then, but you can even forget about what second fundamental theorem calculus was. You don't have to know that one. You can just say fundamental theorem calculus 1. What is fundamental theorem calculus 1? Well, it's that if you have a definite integral and if you know the antiderivative of the function that you're trying to find the definite integral of, you just write down the antiderivative and then you evaluate at 2 points. Where evaluating at 2 points means you evaluate and you subtract. Okay? So this is really x squared times f of 2x minus f of 2. And then step 3, differentiate. And be aware that of any product rule or chain rule. Because sometimes they might be used. For simpler questions, they might not appear, but in most homework questions or exam questions, you will see at least one of these being used. Okay, so let's see what that means for us. We have, by the way, this is our h of x, right? So now we have to differentiate h prime of x, which means you have to differentiate x squared times f of 2x minus f of 2. Do you see this product? What should we use?
By parts? Or no?
No, integration by parts for integration.
Chain rule.
No, product rule.
Oh.
Yeah, you use chain rule later, okay? So product rule, you have x squared prime times f of 2x minus f of 2 plus x squared times f of 2x minus f of 2 prime. And these are easy. X squared prime is 2x. And then you have x squared times, oh, this is a bit challenging. What is capital F prime of 2x? Oh, sorry. When you differentiate this, what rule should you use? Chain rule, right? So the chain rule says you differentiate the outside function. Right? And then you multiply by 2. Why 2? Because the chain rule says the inside function must be brought outside and you differentiate. That's chain rule, right? Remember the chain rule? F of g of x, if you differentiate, the g of x should be pulled out and you differentiate that. That's what happens here. Okay, and then this last part we discussed last time as well. What's the derivative of f of 2?
It's a constant, so it just gets to be 0.
Yeah, it's a constant, so it's 0. So this is like you plug in 2 first, and then you differentiate. So it's a constant, so you differentiate, you get 0. So it'll be 0. Now, you can also use the chain rule if you want. So you can say, oh, it's f prime of 2, but you bring the 2 outside and differentiate. What's 2 prime? 0, right? So that's another way to say it's 0. Okay, so that's it. Except that there's this last step where you have to figure out what f prime of 2x is. So let's think about that one. So I would say step 4, resolve any derivatives you see. So I see f prime of 2x, that's still there, right? In this answer, these are okay, it doesn't have any derivatives, but this one, f prime. Yes?
Wait, so why would you use the chain rule only on one of the x's?
You can use both. I said you can use both, right? If you use chain rule here, it's f prime of 2 times 2 prime. 2 prime is 0, so it's 0.
No, I'm talking about like this is the 2x.
Oh, this one, x squared is not a nested function. So there's no need for chain rule. I mean, you could use it as a chain rule thinking x is a nested function, but it doesn't lead to anywhere, right? Because x squared differentiates to 2x, and you bring the x out and differentiate, what do you get? What's the derivative of x? Derivative of x, what is it?
Derivative x.
1. Derivative of x is 1, and multiplying by 1 doesn't do anything, right? Okay. All right, so I was talking about this one. Let's figure this out. What does that do? Well, that means I already know f prime of x, right? It's this. And I need to know what f prime of 2x is.
So
And,
sine 2x over 2x.
That's right. It'll be sine 2x over 2x. If you see it, that's great. Okay? If you don't see it, then try doing this. First, rewrite this definition as f prime of parentheses equal to sine of parentheses over parentheses. Right? That's what this is what this means, right? Whatever goes in here, you should put in here and here. That's what it means. Okay? But I specifically want f prime of 2x. So what do? I write in 2x here, which means I have to put 2x here and here as well. Okay. All right, so here's what we have so far. We found out that h prime of x is 2x times f of 2x minus f of 2 plus x squared, and then f prime of 2x is sine 2x over 2x, and then you multiply by 2. I guess 2 and 2 cancels. Okay, now we are almost there. Now we can plug in 1 for x and calculate h prime of 1, which is 2 times 1, f of 2 minus f of 2, plus 1 squared, sine of 2 over 1. What's f of 2 minus f of 2? 0. And what about this? 1, 1 doesn't matter, so it's just sine of 2. That's it.